So we mentioned that pressure is a force applied over an area. Kinetic molecular theory predicts that gases would exert a pressure. The pressure is the result of these constant collisions. There are collisions between the particles as they run into each other and between the particles and the surfaces around them. So because of gas pressure, we can drink from straws, we can inflate basketballs, we can breathe. Who likes breathing? I like breathing. In and out, in and out. We can breathe because gases have pressure. Wind comes about as a result of variations in atmospheric pressure. Often those come about because of temperature, and by looking and studying those pressure changes, we can predict the weather to some extent. The pressure of a gas is, again, force per unit area, and what pressure a gas exerts is going to depend on several things, including how many particles are in a particular volume. So here we have two jars. This one has more gas particles, and this one has fewer gas particles. And if you imagine these bouncing around, and each time they hit the walls, they exert a small force, this one is going to have higher pressure because these are hitting the walls more often. It's a little bit like being pummeled by a kindergartner, right? They come up and they punch you, right? It doesn't really hurt. But if you've got like 10 kindergartners around you and they're banging on you, it gets annoying after a while, right? So this is a whole bunch of kindergartners punching you. Pressure differences have an impact on our ears. If you go to a higher elevation, go up the mountains, say to visit Grant Grove, then the atmospheric pressure is less up there. And what happens is you have lower pressure on the outside of your eardrum and higher pressure on the inside of your eardrum, and that causes your eardrum to bulge out, and that doesn't feel very good. If you have a cold or, heaven forbid, an ear infection, that can be excruciating. Well, how does that get equalized? Well, your eustachian tubes that go from your inner ear down into your throat will open when the pressure difference gets significant, and you'll hear this popping or crackling sound, right? And when you come back down the hill, then the pressure difference is the opposite. Now the pressure on the outside is larger and the pressure on the inside is less, and your eardrum's bulging the other way. And again, you have to yawn or chew gum or try to get those eustachian tubes to open up and let some air back in. That's why babies scream on airplanes. It's not because they hate you. It's because their ears are killing them. So pressure's a thing, and we need to be able to measure it. So we have to have some units. The simplest unit is the atmosphere. It's abbreviated ATM. And an atmosphere is just the average pressure at sea level. It is the pressure of the atmosphere. So 1 atmosphere is normal. The SI unit of pressure is the Pascal, abbreviated PA. That's 1 Newton per square meter. So that's definitely a unit. We don't use that much in chemistry, though. A Pascal is much smaller than an atmosphere. 1 atmosphere is 101,325 pascals. I'm only just beginning to remember that number. You don't need to memorize that number. Another unit that seems like a really weird unit for pressure is the millimeter of mercury. Millimeter is a length, and mercury is an element. How do you measure pressure as the length of an element? Well, that has to do with the barometer. So this is a barometer, a very, very simple barometer. We've got a dish of mercury. Mercury is a liquid at room temperature. It's a metal. It has a high density. If you take a glass tube of mercury and you invert it into this dish, it'll come down a bit, but the column here will measure approximately 760 millimeters or 29.92 inches tall. If you did this with water, it would be 10.3 meters tall. The reason we don't make barometers with water is they don't fit in a room. It's just not really very convenient at all. 760 millimeters, 29 inches, that's less than a yard, and so we can have barometers. We used to have them, mercury barometers, in the classroom. They're very cool. So you can measure the height of this, even just with a ruler. This is very, very low tech. Atmospheric pressure pushes down on the dish of mercury, and how tall the column is reflected in the atmospheric pressure. So if the pressure is greater, the column is higher. If the pressure is lower, the column is shorter. Atmospheric pressure, 1 atmosphere, will support a column 760 millimeters of mercury. So this table summarizes the different pressure units. You may need to refer to Pascal's to do some homework problems, but those won't show up on an exam. So here's an atmosphere, millimeter of mercury. This relationship, 1 atmosphere, 760 millimeters of mercury, that is exact. Those units are defined to be equal to each other. 760 torr. Torr is another name for millimeter of mercury. It's named after Torricelli, who developed the first mercury barometer. I think they were hoping that they could get that to replace the unit millimeter of mercury. It hasn't happened, and so now we've got 2 units instead of just 1. Pounds per square inch and 29 inches of mercury. So if you need to do any conversions, all of these are equal to each other. And so pressure conversions can be done in 1 step. You can save yourself a lot of time by memorizing these. An atmosphere is 760 millimeters of mercury, or 760 torr. Those are exact. So let's just do a couple of examples and then we'll call it a day. Convert 1.25 atmospheres to torr. Okay, dimensional analysis, here it comes again. So our path here is going to be very simple. It's just from the given unit to the requested unit. So atmospheres to torr. Bless you. 1.25 atmospheres. I only need 1 conversion factor. I want torr here, atmospheres down there. So the units work out. Then I go over to the table. 1 atmosphere is the same as 760 torr. Each of these is equal to the other. They're all 1 atmosphere. So 760 torr is 1 atmosphere. That's an exact conversion, and so what that means is you just don't consider that in terms of sig figs. You look at what you started with. That had 3 sig figs, and so that's how many my answer should have. So my calculator is saying 950. The unit would be torr. Well, does that have 3 significant figures? Yeah. Kind of, but not really. That 0 is kind of ambiguous, isn't it? We can put a decimal point there. That would make it okay. Or we can say it's 9.50 times 10 to the 2. Inches of mercury to millimeters of mercury. Again, we can do this in 1 step. 30.15 inches of mercury. And I've got millimeters of mercury on top, inches of mercury on the bottom. You can do this as a conversion between inches and millimeters, but students tend to screw that up, so I wouldn't necessarily do that. Just go over here. What do we have for inches? 29.92. Okay, put that in the bottom. And that's equal to 760 millimeters of mercury. So 30.15 times 760 divided by 29.92 equals. I should have 4 significant figures this time. 511.831 millimeters of mercury. 511.8 millimeters of mercury. This number has 4 sig figs. The 760 is exact. The 29.92 is, I believe, 4. Any questions? Yes?
Will we be given the conversions for common units if needed?
Yes. I will give you the conversions.